Okay, so we found out in section 14.6 that we can figure out the equilibrium constant, Kc, if we know the concentrations of the components at equilibrium, right? That's what Kc is, that's an equilibrium. Okay, the next question for this section is, and it's a big one, can we figure out the concentrations of the components if we know Kc? Well, yes, we can, if the system is at equilibrium. Okay? So let me remind you that if we're talking about some reaction, A and B, producing C and D, actually being in equilibrium with C and D, right? Where the molar coefficients of A, B, C, and D are respectively little a, little b, little b, little c, and so on. Okay? So you've seen this several times before, and this is what we're going to be doing. So the question is, if we know this, I'm going to put a box around everything that's known. If we know this, and we know this, and we know this, and we know this, and we know this, can you figure out that? And the answer, of course, is yes. With a unique system that I've created for this class called algebra. Algebra. This is something that I invented for this class, and we can do that by rearranging the equation. Of course, we will have some more complicated questions to do in this section, but the simplest ones are simply going to be rearranging. By the way, I'm going to do a couple separate videos here because this section is really the magnum opus of equilibria. This is the big deal of equilibria. So we need to give some real good time to this because we're going to need it in chapters 15 and 16 also. All right, so yes, the answer is we can figure that out. And so let's do a practice problem, and then we'll be done with this video. So the practice problem is example 14.8, which is in your textbook on page 579. Got some children here at my office working with me, and so there may be a little bit of background noise. Please beg pardon, or give me pardon, please, and I hope that's not too distracting. So consider the reaction. What a mess. COF2. Wow, I don't know what that stuff is, but I bet it smells bad. COF2 is in equilibrium with carbon dioxide and tetrafluoromethane. Okay, so in an equilibrium mixture, the concentrations of COF2, or the concentration is that, okay, I need to write this out. I'm gonna get lost if I don't. It's an equilibrium, it's two of those, equilibrium with carbon dioxide plus tetrafluoromethane, or naming this like we did in section 3.5 intro, we call that, I don't know, carbon tetrafluoride. Okay? We don't need an ice table here because we don't have a reaction going, so it's just, I'm going to draw the ice table out, but we already know the equilibrium mixtures because it says in the equilibrium mixture 0.255 concentration of carbon tetrafluoride is 0.118. What is the equilibrium concentration of carbon dioxide? Ah, we don't know that one. Oh, but wait a second. We do know that K is equal to, these are concentrations, so it's going to be concentration of carbon dioxide carbon tetrafluoride over whatever this stuff is. What a mess. That's ugly. Squared, right? Because of your 2. So we're looking for circle. I'm going to go ahead and circle this. Okay? So what I need to do now is multiply both sides by this mess. I'm just doing some algebra here. And that squared is equal to the concentration of CO2, concentration of carbon fluoride. That's not methane. All right. And this is what I'm looking for here. So it looks like if I divide both sides by that, I'm good. So it's carbon, COF2 squared over is going to be what I'm looking for, right? The concentration of carbon dioxide. So let's write this out. K is 2. See it here? 2.00. COF2 is 0.255 squared. And carbon tetrafluoride is 0.118. I need to put this in my calculator. Pretty sure I've got this laid out right. I'm going to be real careful with it. Put it in my calculator very carefully. 0.255 squared times 2 divided by 0.118 is equal to 1.10211. 1.10211. Okay, and that's going to be molar, right? Because these are concentrations. And then I'm going to finally ask myself, what are the sig figs here? So it looks like there's 2 sig figs here in the K. Right? You see it here? Oh no, that's 3. Whoa. 3 sig figs are right here, right in the K. My 0.255 is 3 sig figs. And 0.118 is 3 sig figs, right? Okay, so these are all 3 sig figs. This is going to have to be 3 sig figs here. Can you read my writing? I didn't leave myself enough room here. This looks like it's going to be 1.10 molar. Okay, and there is my answer. 1.10 molar. All right, so the answer is, the question is, can we find the equilibrium concentrations if we're of some things if we're given the others and Kc at equilibrium? The answer is, of course, yes.